Hi, my name is Ethan Byrne. This presentation was created as part of my senior design project, which I served as team leader for. The project is titled Sunshade Structure for Galvez Primary, and my teammates are Noel Curole, Daniel Davison, Ryan Hoff, Reed Holdridge, and Tommy Wynn. Our advisor for the project is Dr. Mary Beth Lima. Our co-advisor is Brooke Morris, and our sponsor is Sarah Gray. So a little overview of our presentation. We're going to start with some background information, then we'll give you the problem statement, measurable design objectives, our design analysis, our detailed design, the budget, and the conclusion. So pictured on the right is part of our design team, and I'm on the left. Daniel Davison is in the back, Reed Holdridge is on the right, Dr. Mary Beth Lima is in the center, and Sarah Gray is on the bottom. Sarah is the founder of the LSO Foundation, and she is sponsoring this project. So we're partnered with the LSO Foundation to design and build a shade structure for Galvez Primary School. And the LSO Foundation stands for Lauren Savoy Lynn. And Lauren was Sarah's best friend in high school and college. And Lauren developed skin cancer and passed away. And Sarah created the LSO Foundation to help spread awareness about skin cancer and to also help prevent it. So the LSO is a nonprofit organization, and they're contributing $5,000 to the shade structure at Galvez Primary, and Galvez is going to match the $5,000, giving us a $10,000 budget. So some background information. The National Recreation and Park Association has stated that shading playgrounds is extremely important. We all know that UV radiation is very damaging as far as causing skin cancer. It's been shown that one blistering sunburn doubles the risk to develop skin cancer later in life. And a major hurdle that the LSO Foundation is having to overcome is the fact that shading a 10-foot by 10-foot area on the playground costs an average of $10,000. Here are a few of the different types of shade structures, and the one on the right is the shade sail, and that is the preferred style of the LSO Foundation. This is Kenilworth Park, and the shade sails that you see here were designed and installed by the LSO Foundation. The cost of this shade structure was $38,000. And this design is what we're going to model our design after. The problem that we have is that we need to design and implement a durable shade structure for Galvez Primary for under $10,000. And our design needs to be reproducible. And we need to develop a procedure that the LSO Foundation can use in the future when shading other playgrounds. Our measurable design objectives are to shade a minimum of 50% of the swing and composite structure area at Galvez Primary, and we need to do this during the times in the months that the kids are at school and playing. We need to complete this project for less than $10,000, and we would like to complete the build by March 6, 2017. Of course, this date is contingent on getting FEMA clearance for us to do the work because the school flooded back in August. Some of the design tools that we use for this project are the functional decomposition, physical decomposition, morphological chart, Google SketchUp, and AutoCAD. So here's our detailed design. On the left you can see the layout for the shade cells, and on the right is a 3D model that we created using Google SketchUp. This is a video that we created using Google SketchUp, and it allowed us to do a shade analysis of the structure. So as you can see, we were able to model the shade coverage at different times of the day and different times of the year. And once our analysis was complete, we determined that we were able to cover 55% of the swing area, but only 47.2% of the composite structure was covered by our shade cell, but 12% of the area is shaded by the existing structure, so we're able to meet that objective. For the design analysis, we also had to calculate the forces that would be acting on our structure due to wind. And to do that, we used this graph, and it's a plot of porosity and pitch of the roof against the force coefficient. And by using this graph, for a structure similar to ours was put in a wind tunnel, and that's how they collected this data. And the structure is very similar to ours. So we were determined that the force coefficient was 0.225 for our design, which is a 10% porosity and a 10-degree pitch. And using that number and a wind speed of 115 miles per hour, which is 15% more than the 100-year storm in the Baton Rouge area, we were able to determine that the uplift force that our structure would experience is 970 pounds per pole. So once we had that force determined, we were able to start designing using strengths and stress analysis. And using that 115 mile per hour wind speed and the force that we calculated, we were able to determine the pole size, and we're going to be using the 6-inch diameter pole for all of our pole heights. And once we had the force determined, we could then design the footings. The footings are designed to be 15% greater than the uplift force. So to do that, we had to calculate the volume of concrete that would be needed to give us a weight greater than the uplift force. And for the central pole, our footing size is going to be 3 foot by 3 foot by 2 foot 6 deep. That'll be a spread footing with rebars top and bottom and anchor bolts for the pole to bolt to. For the smaller poles, we're going to use a cylindrical footing, and they will be 1'6" in diameter and 2 foot in diameter, depending on how many shade cells attached to them. And they'll be 5 foot deep. This is our budget. Originally, when we started working the numbers for our design, we were over budget, but through some working with our sponsor and our advisor and some careful consideration, we were able to make some adjustments and get the price down to below $10,000. And what that means for the LSO Foundation is that their original designs that they were using were about $100 a square foot. We were able to reduce that cost to less than $10 a square foot. So, in conclusion, we were able to use the design tools and engineering knowledge that we've gained through our time at LSU to successfully design and model a shade structure that will meet all of our objectives. Initially, we were over budget, but we were able to work and get within the budget while still meeting all the LSO's requirements. And the most meaningful part of this project has been the chance to help the LSO Foundation carry their message further by reducing their cost to build. And it gives them the chance to touch more lives and to potentially save lives. These are the references that we use for our project. And thank you very much.